There has been significant movement in the artificial intelligence infrastructure sector recently. Reports indicate that OpenAI has entered into a definitive agreement to acquire Astral. This is not merely a financial transaction, but a strategic architectural pivot. Astral is the company behind high-performance Python tools like UV, Ruff, and Tye. By bringing these assets in-house, OpenAI is signaling a shift in priorities. They are moving beyond just model releases to prioritize developer experience and tooling efficiency alongside model capabilities. This decision fundamentally alters how we should view the future of large language model infrastructure. To understand the magnitude of this move, we must first look at the standard integration patterns that have dominated the industry. Traditionally, when a major technology company builds a new platform, they often rely on existing open-source ecosystems. They treat tooling as a separate layer. Developers would fetch packages from public registries, manage dependencies independently, and assume that the underlying infrastructure would handle the heavy lifting. This approach worked when the scale was manageable. It worked when the volume of data processing was linear. However, the demands of modern artificial intelligence systems are not linear. They are exponential. Here is the thing that standard patterns often miss. High-volume, low-latency data systems require a unified orchestration layer. You cannot simply bolt on a new package manager when the core engine is running at peak load. When OpenAI integrates Astral, they are not just adding a tool. They are integrating a specialized orchestration layer that handles dependency resolution and code analysis at a speed that standard tools cannot match. This is the architectural blueprint we are looking at. It is a move from a fragmented ecosystem to a unified internal infrastructure. Consider the implications for the Python ecosystem. Python has become the lingua franca of artificial intelligence. Almost every large language model is written in Python, yet the tooling that supports this ecosystem has historically been fragmented. Developers would use one tool for package management, another for linting, and a third for type checking. Each tool had its own overhead. Each tool required its own configuration. This created friction in the development pipeline. It created bottlenecks that slowed down the iteration cycle. When you are training a massive model, every minute counts. Every second of latency in your development environment translates to days of lost compute time. Astral solves this by unifying these functions. The UV tool is designed to be a drop-in replacement for traditional package managers, but operates with a different underlying architecture. It is built to handle the complexity of modern dependency trees without the performance penalties of legacy systems. When you bring this into the core of an artificial intelligence company, you gain control over the entire supply chain. You control how packages are resolved. You control how code is analyzed before it ever touches the training pipeline. This reduces the risk of supply chain attacks and ensures that the code running on your infrastructure is optimized for your specific hardware. Now consider the architectural contrast. Standard integration patterns rely on external dependencies. You trust a third-party registry to provide the code you need. You trust that the code is safe and compatible. With Astral, the trust model shifts. The company becomes responsible for the integrity of the tooling itself. This allows for deeper integration with the internal systems. For example, the Ruff linter can be configured to understand the specific constraints of the internal models. It can flag issues that a generic linter would miss. This level of customization is only possible when the tool is owned and operated by the same team that owns the models. This acquisition also highlights a growing industry trend. Major artificial intelligence labs are acquiring specialized open-source tooling companies to secure competitive advantages in the developer ecosystem. It is no longer enough to just have the best model. You must also have the best pipeline to build and deploy that model. The race is shifting from model parameters to development velocity. If you can iterate faster, you can learn faster. If you can learn faster, you can improve your models faster. This creates a feedback loop that is difficult for competitors to break. The integration of these tools will likely accelerate OpenAI's internal development velocity. It will enhance the performance of its Python-based artificial intelligence infrastructure. We are talking about high-volume data systems where latency is the enemy. In these environments, the difference between a second and a tenth of a second can determine the success of a deployment. By controlling the tooling, OpenAI can optimize for these specific constraints. They can tune the package manager to work with their specific storage solutions. They can configure the linter to run in parallel with the build process. This is the power of an integrated orchestration layer. It is worth noting that this move signals a strategic shift for OpenAI to prioritize developer experience and tooling efficiency alongside model capabilities. They are moving beyond just model releases. They are building an ecosystem where the tools themselves are a product. This creates a sticky environment for developers. If you're used to the speed and reliability of Astral, you are less likely to leave the platform. This locks in the developer community and creates a barrier to entry for competitors who rely on standard tooling. There is also a security dimension to this architecture. The research surrounding automated safety testing suggests that external tools can be used to evaluate large language models. By internalizing the tooling, OpenAI can implement safety checks directly into the build pipeline. This ensures that unsafe code never reaches the production environment. It creates a continuous safety net that evolves with the models. This is a proactive approach to security rather than a reactive one. The term Astral in this context refers to the software engineering company, distinct from unrelated projects with similar names. The acquisition signals a commitment to the long-term health of the Python ecosystem. It shows that the company understands that the quality of the software is just as important as the intelligence of the model. Without the right tools, even the most advanced model cannot be deployed effectively. This acquisition bridges the gap between theoretical capability and practical application. Looking ahead, we should expect to see more of this pattern in the industry. As artificial intelligence systems grow more complex, the infrastructure required to support them must grow more sophisticated. The separation between model and tooling is becoming obsolete. The future belongs to companies that can unify these layers. This acquisition is a clear signal that the era of fragmented tooling is ending. The era of integrated, high-performance infrastructure is beginning. This move highlights a growing industry trend where major artificial intelligence labs are acquiring specialized open-source tooling companies to secure competitive advantages in the developer ecosystem. It is a recognition that the battle for dominance is not just in the model weights. It is in the developer experience. It is in the speed of iteration. It is in the reliability of the pipeline. By acquiring Astral, OpenAI is positioning itself to lead this new phase of development. In summary, the integration of Astral into OpenAI represents a fundamental shift in how artificial intelligence infrastructure is built. It moves from a reliance on external dependencies to a unified internal orchestration layer. It prioritizes developer experience and tooling efficiency alongside model capabilities. This strategy will likely accelerate development velocity and enhance the performance of Python-based systems. The implications for the industry are significant. We are witnessing the consolidation of the tooling ecosystem around the leading artificial intelligence platforms. This is the architectural blueprint for the next generation of artificial intelligence. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.